Check one, 2, 3. Hey everybody, it's Michael Helms, also known as Michael the Sound Guy, and this is the Location Sound Podcast. You know, each episode we talk with location sound mixers, boom ops, and other industry pros about the various aspects of recording sound on location, whether it's for feature and independent films, TV commercials, interviews, any time where dialogue from actors is recorded. I started my career in the recording studios in New York City with some of the big artists back in the day, and later on projects for networks like HBO, Sci-Fi Channel, and the Cartoon Network. As time went by, I got out of the studio and began working in production sound. Whether you're a seasoned veteran or just starting out, thanks for joining us. Okay, my special guest today is the founder and president of Zaxcom. Please welcome Glenn Sanders.
Hey, Mike. Thank you very much. It's really nice to be here.
Let's set the stage for those of our listeners that are just starting out and may not be that familiar with Zaxcom. Could you kind of give us a short overview of Zaxcom and the products?
Sure. Well, basically, as a company, we've been around since 1986. I started the company kind of after I worked in video post-production in New York City. Started to make things called time-based corrector control systems, which are something I invented to help in the video post-production process. Was lucky enough to get a Emmy Award for that, so that was pretty cool. And then we moved into digital audio mixers for television post-production. And when I saw basically that whole area was going into, a single computer with Avid and other companies later, I kind of said, well, they're not going to need post-production consoles anymore. So I figured I should probably get into the production area and saw a real niche in changing the way people record. So I decided to go into the location sound business with the Diva recorder, which originally the first one was called the Diva 2. Basically, that's what started us into the whole post-production area. And that was around the year, like 1996 or so. I mean, now when it comes to what we do today, we still make recorders. We make the Nova 2 recorder. We're out of production on the Diva right now, but our focus has really turned to wireless microphones and IFB and that kind of technology because I think, we're good at it. And, we started the ball rolling in this area roughly 23 years ago. We were the first company to actually invent a digital transmission wireless microphone. And we did it at a time when the industry said it cannot be done. There's no way you could build a digital transmitter into something the size of that would have to be a body pack to go on an actor. The one thing that I do is I really like a challenge. And when someone says it can't be done, it's just basically all the more reason to do it. So that's our focus today, our main focus. But, we've put together the wireless microphones and recorders in a way that no one ever did before, where it's all now with Zaxcom, pretty much totally integrated system of recorders having built-in receivers and transmitters and functionality that just never existed before.
Now, Zaxcom has its own ecosystem, so kind of a complete audio system. Can you kind of give an overview of that?
Yeah, sure. So if I use the Nova as an example of that, basically the recorder, our recorder, the Nova, has 2 slots in it for receivers that can slot into it. And when I say slot in receiver, I don't mean slot receiver like people would think of the kind of slot receivers made by Electrosonics or other companies. They are a specific slot that we designed that accomplishes the goals and needs that we have. Because of that, we have time code integrated into the system. We have basically the ability to have the recorder without any external devices receive up to 8 channels of wireless, because every other manufacturer that makes a recorder uses external boxes to have the receiver channels, and those come in different forms today. But with us, it's internal to the recorder, and the recorder has a remote control transmitter. Actually, that transmitter is called a Zaxnet transmitter, and it's a 2.4 gig transmitter. And we invented Zaxnet. It's the only transmission from any recorder that contains IFB audio, time code, and remote control. So with this one transmission from the recorder, you get to basically have a really great ecosystem from your sound bag. And when you look at the sound bag, you basically see a sound bag that is ultra tiny. I mean, our sound bags are really not much bigger than the recorder. In fact, there's a company that makes something called a feather rig, which is sort of like this exoskeleton, and it puts a battery on the recorder and maybe a few other little accessories, but you're carrying something over your shoulder that's maybe 4 pounds. And previous to what we've done, sound bags typically weighed anywhere from 10 to 20 pounds. So, this has been a huge breakthrough in ergonomics for the sound mixers because, no one wants to carry a 20-pound sound bag. To have something so small, so lightweight, and frankly, so low power, which I didn't talk about because our power consumption with 8 receivers in the Nova is probably half to a third of competing solutions. So, the ergonomics of what we do is just really untouched by any manufacturer or combination of manufacturers. And the ecosystem, providing the remote control of the transmitters, which of course in Zaxcom's case, record and transmit at the same time. So the time code that your recorder has is being broadcast to all the body pack transmitters automatically. They're jamming that code, they're subframe accurate, and anything you do with the Zaxcom ecosystem is totally backed up in the transmitters so that you don't have to worry about dropouts. You can have all the dropouts you want, and as long as you're not doing a live thing, you're safe. You've got all those backups. Whatever the number of tracks you need, you've got them on your recorder, and if you exceed what the recorder can do, you've got the mono tracks in the transmitters as well. We also go as far as to allow the recorder to act almost like a synchronized, not almost, it's a synchronizer, so that if you want to replay, let's say 20 wireless microphones, they will all queue up to a location and you can replay them, and then you can re-record them on your recorder and remix. And there's just nobody that does what we do when it comes to that kind of functionality. And there's much more to it, but that's the basic ecosystem kind of thing that we do.
Okay. Talk a little bit about NeverClip.
Well, NeverClip is really a cool thing. We invented NeverClip quite a long time ago at this point. We were the first to use a dual A to D converter to extend the dynamic range of an input, because basically, when it comes to inputs, and I'm glad you asked me about this because there's other peripheral things associated with NeverClip. When we did it, we realized that the converters had roughly about 116 to 120 dB of dynamic range. That's all fine when it comes to recording in a controlled environment, but often, you've got a situation where your mic preamp is not set up properly. So you want to capture more dynamic range, because certainly if you're trying to really have a situation where someone's whispering on set, your gain's going to be set kind of high on your transmitter. And then if the actor starts to scream, then you're either going to be clipping or you're going to be compressing, more likely compressing. But we figured out that we could use 2 A to D converters in the transmitter and seamlessly put them together to extend the dynamic range so that, people can whisper and then you've got proper preamp gain for that whisper, because we do allow gain control of the transmitter, which is another topic unto itself. But you can be whispering, and then you can be screaming and not clip, because we extend the dynamic range. I believe that we have some transmitters where it's as high as 136 dB, which effectively is the base 116 dB dynamic range of a single converter in our transmitters, plus another 20 dB of the secondary converter. So NeverClip was really an important thing, and something that, again, that we invented. Other people now have their own kind of version of that, but NeverClip has certainly been a big thing for us. And I believe we started with it in the recorders and then decided that we would put in the wireless because it was so advantageous.
Yeah, I like the ZaxNet features, like being able to adjust preamp from the recorder, change frequency. You got all these wonderful controls. I think that's a plus.
Well, thank you. You know, when it comes to talking about the preamps and the recorder, you know, it's kind of funny that if you look at the history of recording, sound mixers, in order to get the best results, have always adjusted the input trim on a preamp. I mean, whether it's a hardwired microphone into, you know, an older console like a Cooper mixer. I mean, production sound mixers have always done this, because the fact of the matter is your signal to noise is always established at the first stage. I mean, that's the way it always is. So whatever your signal to noise level is, your microphone preamp determines that. It's not determined later in the chain. Even, you know, today where, you know, the signal chains are digital, but if you don't properly adjust your mic preamp gain on your transmitter or the input of your mixer recorder, you're definitely leaving quality on the table. You know, and this has been the subject of a lot of conversations, because, you know, Zaxcom has always had transmitter gain control locally and remotely. When I think of why we do it because there's no single place to adjust the gain that fits all circumstances. Either you're going to have an issue when it comes to the noise that you would have, basically getting the best noise performance, or you might have a problem when it comes to, again, clipping or hitting a limiter. You know, even with dual A to Ds, that gives you 2 points where your input gain is going to be correct because you've got dual A to Ds. But unless you can properly adjust the preamp gain, especially on the low side where you're trying to pick out people who are whispering, you're causing a deficit when it comes to what you could achieve when it comes to noise level and when it comes to, frankly, dynamic range. So in order to exercise, I use the word exercise, the A to D converter's proper number of bits, you need to adjust that gain properly, or, you know, you're not going to get the best results. And I will say, can you get good results by not doing that? Yes, you can get good results. But our customers who are recording motion picture and television, they're not looking for good results. They're looking for the best results. And, you know, there's no substitute for adjusting the gain of a transmitter. That's how you get it. If you don't, you simply don't. We were actually the first to put in remote control of the transmitters. And I mean, basically, when we came up with digital recording wireless, and there's a funny story on that, and I know stories are good. When we came up with the digital recording wireless, I basically wanted to throw everything into that, including the kitchen sink, but it wouldn't fit. But in any case, I did it because, you know, we came up with digital wireless. You know, the first thing was just to have digital transmission and transmission reliability. And I ended up getting asked to go to a very, very large live venue company that used a lot of, you know, handheld microphones. They basically did stage concerts and what have you. I mean, they're really big. I'm not mentioning names, but, you know, so I went out there and I gave them a demonstration, and they listened to our handheld and they said, "This sounds absolutely amazing. We've never heard anything that sounds like this," because, of course, everything they've ever heard was analog FM transmission. I said, okay, great. And they're like, we're really happy. And the next words out of one of the two owners' mouths was, how many are you going to give us? Now, this was at a time, Zaxcom's not a big company. So my response was, well, I can't give you any. If you'd like to purchase some, we'd love to get you as a customer and sell you equipment. Like, oh, no, we can't buy anything because everyone gives us everything for free. Because, people want to see Madonna holding a Shure microphone or a Sennheiser mic or whatever it happens to be. So, we don't pay for the gear. I ended up leaving there. On that drive home, I just said to myself, what do I need to do to get into this market? Because the one thing that I figured out was that for any sound mixer or any company that is heavily reliant on one brand of wireless or another, they just don't throw that away and buy all new. They don't do it. Same thing for rental houses. They just don't. So I said, well, you know what? I'm going to put recording in the transmitter. I'm going to put time code generator in the transmitter. I'm going to put remote control in the transmitter. I'm going to do all these things. And, at that point, if I can't be successful and get a good bunch of customers, then I'll just go do something else. And luckily, it worked.
Now, speaking of that, you have a plug-on for a boom pole that can be a recorder as well with timecode.
Well, that's right. Actually, we have a few. Actually, two right now. We made the first plug-on that had stereo transmission. Of course, it's digital stereo transmission and still is the only digital stereo transmission. And it has Zaxcom in it, so you can remote control it on the pole, and it does record. And it handles AES-42, so that you can plug in Super Cement microphones or any AES-42. Again, it's the only one out there that does all of that. And we had that for quite a while now. I would say at least maybe 15 years. And like I said, it's still pretty unique. But what we did do since then, we have a transmitter, which is our most popular, called the ZMT4. And it is literally the size of a Zippo lighter. It's half the size of any of our competitors' smallest digital transmitters. And the trick there is it runs for 7 hours on one battery, which is an NP50 battery. But I wanted, also to put everything in it that I could. So I also made it capable of putting out 48-volt phantom and working with a balanced microphone input, besides working with lavalier microphones. So the interesting part about that is it only weighs 2 ounces. So you put that on the end of the pole, behind the microphone. You pull the cable out of the pole, and you just lightened your pole because the cable you pulled out is probably twice or 3 times the weight that you're putting on with the transmitter. And it's become a real standard for cableless boom poles. It's just pretty amazing. And we do get about 5 hours of runtime while supplying the 48 volts. So, and that's a different topic, but I do want to talk about power consumption at some point.
Yeah, let's talk about power roll.
Power roll. Power roll is a feature we put in that we patented, which I think was a pretty cool thing. The idea was that at the time, we had a transmitter called the TRX LA2, and it would do up to 125 milliwatts. But when it did that, the battery life was a little shorter than it could have been because we're outputting a lot of power. And transmitter power has always been pretty involved when it comes to runtime. The higher the power, the shorter the runtime. So I figured out that, well, you know what? Because we have remote control of the transmitter from the recorder, why can't we tie that into the record function of the recorder? And thereby, when we're in stop mode, we can go into low power on the transmitter, because if no one's recording, in stop mode, or I should say in low power mode, it's certainly very easy to still have hundreds of feet worth of distance. If you're going to go from 125 milliwatts down to, let's say, 25 milliwatts, you're giving away about 6 dB worth of signal to noise in the RF chain, which again, when you're not rolling, is fine. So we did that, and we probably extended the battery life of the transmitter about 2 hours by doing that. And I thought it was a pretty smart thing. So we did that. Ironically, the ZMT4 is so power efficient that whether we put out 10 milliwatts, 25, or 50, the power consumption happens to be the same. So it has less effect on that transmitter than it does on some of our earlier transmitters. But if I may, I do want to talk about transmitter power consumption for a moment, because I think that this is one of our really, really exceptional things. If you look at digital transmission transmitters that are out there, we with the ZMT4, again, because it's so tiny, we have to have a tiny battery. And tiny battery means that you don't have a lot of capacity. So we were able to design the ZMT4 to get the power consumption down to a level that was crazy low. I mean, the transmitter only draws approximately 125 milliamps at 3.7 volts, which is not a lot of power considering the transmitter, internal receiver, internal recording, the 48 volt mic power if you're using it. So we're able to get a very small package and get this very long runtime in it that's just absolutely unheard of, unmatched by anybody today. And this is one of the things that we're just fanatical when it comes to getting every milliamp of power consumption out of that transmitter, and it's really paid off for us.
Well, let's talk a little bit about the IFB setup that you have for Zaxcom.
Sure. IFB is an interesting thing. We came into the IFB market about 10 years ago, so it's been, actually maybe a little longer than that. Our first IFB was a 2.4 gigahertz receiver that receives our ZaxNet signal. And we were the first IFB, first of all, to be digital in transmission, but we also combined timecode with that. So if you had our IFB receiver, which was the ERX, you could not only output, really good sounding IFB audio, but you could also use it as a timecode transmission sync box, because any of the receivers at the touch of a button could output timecode. And the timecode was it was always subframe accurately jammed. You never had to jam anything. So, we kind of eliminated the whole process of having to, run back to the sound cart to jam, your slate or jam cameras, that you could just bring an ERX around and jam everything, which was great. But the 2.4 gigahertz range for audio transmission was a bit limiting, just because of the nature of 2.4. And that was also a true diversity receiver, which was a great thing. But still, 2.4 was limiting. So we decided to make a new UHF IFB and to tie it into our transmitting system, or the whole ecosystem. So today we have two IFB receivers, a higher end unit called the URX 100, a lower end unit called the URX 50. And both of those units they're multi-channel, so you can listen to your sound cart, your sound bag. But for the first time, you were able to program these units so that you could listen to all the body packs as well. So you didn't have to go to the sound cart and open up a fader in order to QC something. The A2 could go around and listen to all the packs without bothering the sound mixer. It became a function that did not require sound card intervention to QC and monitor. And of course, there's many other things you can do with it. You can let script supervisors listen directly to individual actors or what have you. So the IFB system became something much, much more valuable than the typical FM receives one channel companded thing. And I think it's universally accepted that, FM IFB doesn't sound great. Some people like that, some people don't. my opinion is IFB should always, as best as possible, represent the true sound of the production. If you're willing to accept what is the current standard for IFB as being, something lesser, I mean, so be it. But that's not what we do. We're always looking to improve on IFB, but the big thing was the integration of it into the ecosystem, because, transmitters and IFB and recording are all very, very much tied together, even in so much as all the IFBs also display the system time code, so that if you're, basically a script supervisor, you're making notes, you can look at your IFB receiver and note the time. In fact, the IFB receivers have a hold function, so that if you want to freeze the time code when something happens, you can do that, and then you can make your note. So again, it became very much a new tool, and again, part of the whole system. So again, we did that, and still today, there's no one that does that kind of thing but us.
Now, did I read somewhere that there are no intermodulation issues with Zaxcom transmitters?
Well, that's correct. From day one, we chose to make our transmitters in a different way than the people that made FM transmitters. Other companies have now followed our lead because, frankly, the technology requires that you utilize what's called a Class A amplifier. FM is Class C. Class C is very nonlinear in nature, just because that's just what it is. The reason that people use Class C is it's very, very power efficient. Well, by using Class A, it's so linear that transmitters, when they get close together, do not affect each other. The problem with the Class C transmitter is if you take two Class C transmitters and hold them a foot apart, each transmitter will receive the other transmitter, even though they're not receivers, but it'll receive it, mix it with its own frequency it's transmitting, and then put out these what are called intermodulation products. And the FM wireless manufacturers dealt with that in different ways. In higher end units, they used something called a circulator, which was like something that just prevented the mixing in the transmitter to a certain degree, not totally. But using these Class A amplifiers eliminated the problem. And it's kind of interesting because, you see a lot of manufacturers who have these intermodulation programs. And, intermodulation programs are good in figuring out where the intermodulation problems are. But the one thing that I know is sound mixers are interested in one thing: getting great audio. If they have to use an intermodulation program and they have to monitor that and they have to constantly be up on what's happening in real time, combining with that just becomes a whole nother job. So, we've always been of the opinion that with our systems, of course, you could throw other things into the system that aren't Class A, but with our systems, you don't have to worry about intermodulation. If I have two transmitters a megahertz apart in their spacing, I can have two more transmitters that are another megahertz apart. In other words, you can evenly space your transmitters without the worry that you're creating all these intermodulation products that with FM systems and probably some other digital systems make things unusable.
You also have modulation choices. So you have ZHD and XR.
Yeah, let me explain that for a moment. Basically, with the modulation, we started out with what we call monomodulation. Monomodulation is basically a very high bit rate, very, very lossless. In fact, there's very little compression on it, data compression. We use data compression in everything because we have lossless compression so that there's no artifacts involved with it. Basically, in the beginning, when we were a little naive, because we, like I said, we invented digital wireless, we wanted to make sure we had as many bits going from the transmitter to the receiver as we could. So we came up with monomodulation and then shortly thereafter stereo modulation, because we realized that we were actually sending a lot more in terms of data than we really needed to send lossless audio. So after a while, we said, well, you know what? We can get better range if we have different modulations that do different things. So we have what's called XR modulation, which stands for extended range. And XR modulation is extremely decodable. And also at the same time, we kind of solved a problem that came up as a result of Zaxcom doing digital modulation. If I go back to the beginning, so at one point in LA, I was on a set of a TV show, and for the first time, someone was using Sankins on our transmitter. This is probably around 2002, 2001, something like that. So they were using these Sankin mics, and I remember hearing a 2 kilohertz sort of whine in the audio. And I'm like, okay, that's not good. And when you move the mic around the transmitter, the level of it would change. It would either go away or get louder. Okay, so that was when I realized there's something going on here. So I actually ended up contacting Sankin and saying, hey, there's a problem here. Your microphones have RF issues. And they basically said, no, we don't have that. I said, no, you do. And it wasn't just them. It was basically everyone. It was, everyone kind of describes everyone without naming a lot of names. It was kind of funny because I had to literally go to the Sankin booth at NAB, and they had a microphone called the Cub One. And I remember I brought a transmitter, and their engineer was there and telling me absolutely there's no issue with anything. And I held the transmitter up to the Cub One, and they had a little listening system, and pretty much louder than the noise floor of the microphone by a big margin, you heard this 2 kilohertz tone. And then they said, oh, yeah, I guess there is a problem. To their credit, the result of that was the Sankin COS 11D, which they took care of the RF issue, and basically we were in pretty good shape from that standpoint. And everyone has stepped up to the plate when it comes to that. It's really not a big issue today, just with legacy microphones. But, I got off a little topic here. So the XR modulation helped with that because XR modulation doesn't vary its amplitude so much. It does a little bit. But digital modulation is a combination of amplitude changes and phase changes of the signal. It's the amplitude change that causes the problem. So XR is better at that and gave us but it gave us an improvement in our range. And now we have something called ZHD96, which stands for Zaxcom High Density. And this modulation is really great because, number one, the range of it is exceptional. It is much better than other modulations when it comes to reflections. Because what I didn't mention is the reflections that you get when you're in some sort of atmosphere like a stadium that's enclosed, where you've got a closed roof, or maybe you've got obstacles in your way. Maybe you've got trash dumpsters, you're on a street, you've got walls, you've got metal fences. These reflections can really ruin a digital signal. And ZHD is specially formulated so that it is much more immune to the kind of reflections that cause dropouts. That was a big advantage there. The other thing about ZHD is it's very, very narrow in terms of its bandwidth. The maximum, boy, I'm just spouting out all these figures here. I hope it's not too much. But the maximum allowable bandwidth of a signal is 200 kilohertz, which is plus minus 100 kilohertz, well, from the center of the carrier. And what we did with ZHD96 was cut that in half. So, the signal being half the bandwidth allows us to get channels much, much closer together. In fact, if you plan properly, you can actually get the signals to be within 200 kilohertz of each other and thereby have really twice the number of channels available, than you would if you had a modulation that was 200 kilohertz wide. It's really a great tool. And I think ZHD96 has become, like I probably said, a lot of people's favorite modulation. That's kind of a modulation story.
And you have those options.
You definitely have those options. I think one or two of the other manufacturers might have more than one modulation, but at this point we're up to 4 main modulations on our stuff. And, the great part about that is you just decide what's best for you depending upon your environment. Stereo modulation is a real big thing for us. In fact, I think some of the other people that have been on your podcast have talked about our work with the NFL. And NFL, exclusively uses our stereo modulation to get 2 microphones on each player. I know Adam talked about this a little bit. So that's a pretty cool thing that, one body-worn transmitter can do that. So again, the modulation depends on what you're doing, but generally speaking, there's something for everybody.
Okay. Well, what drives you toward all this new product innovation?
A lot of things. I would say, innovating and inventing is just something that I've always wanted to do. I remember just being a kid and just wanting to, come up with circuits and different things that just didn't exist. And, I think it's a lot about problem solving for people and also looking at the status quo sometimes and saying, why isn't anyone doing better than that? We can do better. I remember one of the very first reasons that we got into location sound was back in 1995 when I think I started looking at building the Diva recorder, was that all location sound acquisition was tape-based. It was DAT tape, it was Nagra, that was it. And I looked at it and said, I think we can do better. But the thing that got me going on that was Nagra came out with I think it was a handheld solid-state recorder. And in the ad for the recorder, because I saw it in a magazine, it said that the recorder was effectively the new standard for motion picture and television recording. And I just said to myself, no, this isn't going to work. No one's going to use a handheld recorder that can only record, maybe, I don't know, I think it could do 15 minutes on a card at the time or something. I said, no, this isn't going to work. So I knew that there was an opening to build a product that was going to hopefully change things for the better and also, allow me to be successful as a manufacturer. A lot of times the term necessity is the mother of invention. That's still true today. But I really wanted to focus on things that hadn't been done. If I look at the list of things that we've done over the years, certainly the multi-track solid-state production sound recorder, we invented pre-record, we integrated metadata into the process. I don't want to use the word invented because certainly metadata existed in post-production, but we put it in. Pre-record was a big one, though. For those who may not know, basically it was the process of just buffering the audio constantly, and then when someone hits the record key on the recorder, laying that down for 10 seconds before the actual time that the record button was pressed and doing it with time code accuracy. That was a big one. I thought that was cool.
I use it all the time.
There you go. Or I remember showing it live to a bunch of sound mixers in the UK in a room of 50 sound mixers showing the Diva for the first time. I literally stood there and said, okay, we're not in record. Okay, I just pressed the button. Now we're in record. And then playing it back. And when they heard me saying we're not in record and then seamlessly going into the recording, I got applause in the room from everyone. It was just a nice thing I'll never forget. But yeah, so we did that and we invented NeverClip, as you mentioned, the power roll, which is a great thing. And of course, digital recording transmitters. So we've just done so much. The one thing that I can't do is just sit around and look at what the status quo is and be happy about it. And, The one thing that I won't do is I won't make a product where there are good solutions already available. If I'm already in the market, it's one thing, but I won't go into any area where I feel that there's already a tool out there and we can only match that. So, and I will tell you, things are coming. I won't go further than that, but we do have quite a lot of new technology that we've been working on, and all compatible with what we already have on the market, so no one has to worry about anything. But Muppet Labs is fully functioning, as I like to call it.
Well, what's the biggest technical challenge you've had to deal with and to overcome with some of your product development?
Biggest technical challenge? I would say most everything that doesn't exist is a technical challenge. I would say the biggest one was inventing digital wireless. Just the process of starting with nothing and just even learning about what solutions might be available and then trying to shoehorn it into a body pack with a couple AA batteries to make a digital transmitter always took a rack-mounted piece of equipment. That was probably a huge one. The Diva was pretty challenging. I think probably one of the biggest problems that we had when we did the Diva was that the biggest hard disk we could buy was 700 megabytes at the time, the biggest drive we could get. I took a risk that there would be bigger drives out someday. Luckily, it didn't take too long because there certainly were. That was a good thing. But what do they say? Any great technology is almost indistinguishable from magic, Challenges are good, If you don't get challenged, you don't learn things, you don't stretch and what have you. So everything we're working on now is I would say, challenging. It's the nature of the game. It's what we do.
For sound mixers that maybe have gone down the path of with another manufacturer and they wanted to, say, switch to Zaxcom, it's a commitment, right?
Well, yes and no. You don't have to go cold turkey, as it were. You don't have to do all or nothing. You could have recorders from our competitors, and you can add our IFB, you could add our wireless. Do you get all the benefits? No, you don't. But you still get benefits that are so substantial that to not consider our products, I just think people should consider. If you look at even just in terms of recording wireless transmitters, because we're the only one in the United States that can do recording wireless transmitters because of the patents. Just that function alone is worth the price of admission. If you look at the amount of time and effort spent by sound mixers and productions to put up antenna systems that can cover multiple areas, to eliminate interference where you might not even be able to do that, there's so much money and time spent in trying to make sure that you have no dropouts. And I'm not saying that's a bad thing, but if you can use a wireless system that records and transmits, it just gets to the point where you almost don't care if you happen to have a dropout. And that's worth the price of admission, in my opinion. If you're using a recorder by our competitors or using IFB from our competitors or any of those things. So it's a good thing to have choices. There's other companies that make very, very nice products, and some of them do things we don't. And that's okay because we do things they don't, or maybe there are differences in the product. So everyone has a choice. There's no reason to think that you can't use any of our products with products from other companies. They work together and they still provide what I call industry-leading features and abilities when you use them with other companies' products.
Are there any final thoughts you'd like to share as we kind of wrap up?
A lot of what I do and what I've learned about the industry, I have to be very thankful to, especially the sound mixers that I worked with early on, people like Jeff Wexler, Mark Yolano, Billy Sorokin, John Pritchett, of course, Whit Norris, just to name a few. So there have been a lot of people that I've worked with who have taught me what's important, because the process of making features and making television, it runs the range from get the audio, get it quick, we got to get this on camera, we have to get it out there, But also, especially in high-end motion picture, everything matters. Mics on clothing, what the room sounds like, how it's boomed, what the mic preamp gain is. There's a big range of what people expect and what they want. And, we have to work with all those people. We're not a cookie cutter kind of thing. Everyone's different. The motion picture industry, it is so much an art, I've learned, and being on set with these people, because I used to go on set quite a bit before COVID, just learning how they practiced their craft and did their thing. I mean, you don't get that by sitting in a laboratory working on gear. You get that by going out, talking to people, and understanding what they're looking for. And, some of the best ideas we've had for new products and features come from our customers. I like to think we do a really good job at listening to these people. And, the one thing I know is I don't know it all, and I never will. But, you learn every day, and that's really important. And generally speaking, we have a great bunch of people we work with in all aspects of recording and manufacturing and doing what we do. It's, you got to be pretty well-rounded, I think, to run a company like Zaxcom, and hopefully I've done a good job.
Fantastic. If you want more information, check out Zaxcom.com. And there's also a ton of videos, YouTube videos online with a lot more information about what we've talked about and other things too. But I want to say a big thanks to Glenn Sanders of Zaxcom for being on the podcast today.
Thank you, Mike. It was great to be here.
I'd like to say thanks to everyone for listening. If you have questions, send an email to locationsoundpodcast@gmail.com. The Location Sound Podcast is part of the Audio Podcast Alliance, featuring a hand-picked selection of the very best podcasts about sound. Be sure to hear the latest episodes from our friends in the community at audiopodcast.org. Until next time, remember, sound is half the picture.